Welcome once again. Okay, to one more video. The last video we had seen, let me share my screen. The last video we had seen like how to find out the work energy, how to find out the work done by the tension forces. Okay, now let us do one more example. Let me show you the previous video so that you get an idea of what we did. Okay, this is what we done. Okay, what we did was we had a block of mass m. Right. Okay. We had a block of mass m. We lowered it down with a chain. And as a result of it, the question here was that what is the work done by the tension in the string? Okay. Now let us do the next one. The next one is about the famous Atwood's mission. I don't know whether you have heard about this mission or not. It's a very simple mission. So what it does is to lift one object, you need another object. That's the principle. Okay. So I have two masses here. One mass is like this of mass m, other mass is 2m, according to the problem. Okay, it's nothing new about it. So according to the problem, there are two masses. See, a heavier block in an Atwood's mission. So either this could be heavier, this could be heavier. Anything can be heavier. Is twice that of the lighter one. Okay. The tension in the string is 60 Newton. Wow, this is already given. See, it's a blessing. Whenever tension is there, in every problem, tension aa jata hai. Tension automatically comes to a head. So anyway, tension is given here. When the system is set into motion, okay, when system is set into motion, this is what? Why it's so special? Because when the system is at rest, definitely tension will be different. Okay. Then find the decrease in the potential energy during the first second. What is the decrease in the potential energy? Why should the potential energy decrease? Because this mass, it starts from here, it comes over here. After 1 second, might be it will come down here. Okay. We do not know what is the distance. In 1 second, this could be the distance described. Okay. And when it is released from this, that's what it is. How comes the problem? I might think you would have guessed no. Okay, could be something like if the tension multiplied by this one will give you, or maybe this mass 2m multiplied this will give you. But in that case, how do I get this value of m here? M value is not given, right? So this is the one big headache here. Somewhere, see, when there is a number given here, somewhere this value can also be determined. That is something which you should know. Okay. Now let us start with this. And if you ask me what is the misconception here, okay, nobody attempted it. They just left it across. They said, sir, quite difficult. You're not given me the parameters at all. I can't do it. They left it. Okay, many students. Okay, and a few of them do attempt it, but only something like 10% of the problem they were able to break. What they did was they started with the FBDs. Of course, they did it correctly. So now what we will do is we will solve this problem by two methods. Once again, kinematics, work energy. We cannot leave work energy at any cost. Okay. So let us start with that. Now towards it, let us write like this. The free body diagram for this one. This is your tension T. This is your mass 2m. And then 2mg comes over here. So now this is heavier than this. So this should go down with an acceleration A. So now free body diagram for this would be 2mg minus T is equal to 2ma. This is the first equation. Now for the mass m, what will happen? Okay, I'll write it here. For the mass m, this is mg, and you see the same tension will act here also. Same tension will act here. So now the block is moving upwards. So therefore I can now write T minus mg is equal to ma. Okay. Now this is equation number 2. Now I'll add 1 and 2 equation here. Why should I add? Because I don't want tension here. A isn't required. Then will I get the value of acceleration? I do get the value of acceleration. Okay. Let us find the acceleration here. Okay. I add up these two equations. When I add up these two equations, what do I get? I get 2mg minus mg is equal to 2ma plus ma, which is 3ma. 2mg minus mg should be equal to mg is equal to 3ma. Wow, I have eliminated the value of m. A should be equal to g by 3. Quite easier here. I have got the value of A. No issues at all. Okay, but still I have not got the value of m. How do I get the value of m? Simple. Substitute in either of this equation. You see, tension is already given to you. 60 Newton is given to you, right? Let us try that also. So I will use which equation? This equation I'll use. Okay. T is equal to mg plus ma. Or I will write this as m into g plus a. I'll write like this. tension is already given. 16 should be equal to M, I do not know, okay, into G plus G by 3, right? Which should be mg 4 mg by 3, right? I do one thing first. Time being, I just keep this mg equal to okay. Now I have 16 here, right? 16 equal to 4 mg by 3. 4 ones are 4 fours are. So mg is equal to this 3 goes upwards. It should be 12. Okay, mg equal to 12 Newton. Okay, from here I can get the value of m. Okay, m is equal to 12 by g. That I can get it. Oh, my space is not sufficient. I need one more slide. Just give me a moment. I will insert one more slide. Just give me a moment. Okay. Wait. I have to share this one. Okay, fine. So I have got mg equal to 12 Newton. Okay, let me keep it aside. Now let us start with the first method. What is my first method? Kinematics method. Okay, I become a fan of kinematics here. Otherwise, I won't do kinematics at all. Okay. So now, what has been asked? Decrease in potential energy. Now, how do I find decrease in potential energy? I need to find what is the distance moved by. Decrease in potential energy is nothing but you need to find out what is this energy here in lowering down and what is the energy here. What is the work done by the mass in this one and this one. That's what you need to add. You need to add those energies and get the answer. Okay. So towards it, first what we will do is I need to find the distance moved by it. Okay. So distance moved by it. How do I get distance? S is equal to initially the object was at rest. Then it started moving. Okay. After 1 second, where is the object? That's the question. So this should now be equal to S equal to ut plus half at squared. Why you use that equation? Because it's moving with constant acceleration here, right? So therefore, this should be 0 plus half a t squared. What is the value of a? G by 3, which should be half into g by 3. And value of t is 1 second. See, why t equal to 1 second? Because it says after first second. After first second, where is the object? So this should be 1. So which should be equal to g by 6. Wow, we have got the distance also in terms of g. Okay. Now what is that we need to do? We need to find the work done by kinematics. What does kinematics tell you? Kinematics tell you what is the work done by this object, what is the work done by this object. Now you need to be careful. Why careful? The reason is because where is this force acting? Now when I say work done, okay, I'll write it step by step. Work done is equal to work done 1 plus work done 2. Okay. Now if this object is moving downwards, why should it move downwards? Or what is the force acting here? The net force acting here, don't tell me it is 2 mg. The net force acting here is nothing but 2 ma here. Remember, it's not 2 mg. 2 mg is the weight, but there is also a tension pulling upwards. So the negative force is mg, 2 mg. Positive force is t. The sum of these two is one more force, which is 2 ma here. Okay. So work done now will be F1 dot S1 plus F2 dot S2. That's what I need to write. Okay. Now, here what I will do, F1. What is F1? For this one, this should be 2m into A. What is A? G by 3. G by 3 dot S1. What is the displacement? Displacement is also downwards. Force is also downwards, right? When force is applied downwards, only then displacement will be downwards. So therefore, what is displacement here? 2 meters. This is your 2 meters. Is it 2 meters? No, it's not 2 meters. G by 6. I'm sorry, I took it from the previous problem. It is G by 6. G by 6 is the displacement which we have got here. We have calculated here, right? Into G by 6. And what is the angle between the displacement and the force? 0 degrees. So therefore, F dot S1 will be F1 S1 cos 0, which is nothing but F1 into S1. So I will just write like this. Plus, now F2. What is F2? F2 is the force acting here. What is that force equal to? M into A. Remember, this is not mg or this is not tension here. Okay, tension is 60 Newton. So the total force that is acting, net force that is acting here, which is making the object to go upwards, is nothing but ma. Okay, so this is MA. What is MA? M multiplied by what's A? A value is G by 3. I'll substitute this G by 3. Okay, into what is S2? What is S2? S2. See, if this goes down by G by 6 meters, this should also go upwards by G by 6. So therefore, this should be G by 6. Oh, now we have got all this, but I don't have space. Okay, what I will do, I have to go to the next slide only. Or maybe I will lose the continuity. Okay, let me go to the next slide. So I'll write it once again here. We are doing the first method, and I wrote W is equal to 2m. अरे यार मैं भूल गया. 2m into g by 3 into g by 6. 2m into g by 3 into g by 6 plus m into g by 3 into g by 6. This is what I've got, right? Refer to the previous slide. Okay, we have a big notebook, you can start writing into it. Okay, now you see this is common. So this should now be equal to 3m into g square divided by 18, right? 3 into 6, 18. So here I added 2m plus m, or maybe if you want to do multiplication and add, you can do that. Okay, I made it very easy way. And now what I will do is I'll write this as 3 times mg into g divided by 18. Now I hope you would have got the clue as why did I write? What did I write here? I wrote mg equal to 12 Newton from here, right? I'll take this 12 Newton and substitute it here. I'll substitute here and write this as 3 into 12g divided by 18. Now let me simplify. 3 6 are 18, 6 2s are. So thus, what is the unit? Joules. So the answer that you should get is 2g joules. Now if you substitute g equal to 9.8 or 10, we substitute g equal to 10, you get 20 joules. Okay, I'm not interested in looking at the final answer. Okay, let us stop here. Now we have done it by the first method. I hope you understood this. Let me go to the second method. M2. Which method is this? Work energy theorem. Work energy theorem. Now, what does your work energy theorem tell you? Can you think of what does the work energy theorem tell you? Work energy theorem tells you that the total work done is equal to summation of half mv square. Okay, which is half mv square minus half mu square is what tells you. Okay, so thus the work done should now be equal to, now there is no other object which is moving over here. So what I will do is I'll just write half m. What is the m here? Why did I write summation? Okay, that you need to importantly know to it. Because you see there are two objects here, right? One object, let me pull it here. Let me put it. Okay, one object is 2m. One object is 2m. The other object is m here. Other object is m here. There are two objects over here. So I should definitely consider both of them. Okay. V. Sir, in that case, V should be positive, negative here, positive here. You take it whatever you want. But what is happening here? When V is negative, V square becomes positive, right? So therefore, now this becomes 2m into V square plus half into m into V square. Am I right? Okay. Because the same velocity, this also moves upwards. So now you see this V square half is common. So I can now write this as half into 3m into V square. Wow, we got it very easily. But what is V? V is not given to me. How do I find the value of V? Simple. The object started here. Okay. After 1 second, it was here. Okay. We need to find out what is the velocity at this point. Is the velocity given to you anywhere? Velocity is not given. Now, how do I find velocity here? Any idea? How do I find velocity? How do I find velocity? You need to think of how to find the final velocity at that point. Now, what is the distance given here? Distance given here. What is the distance? Distance given to me was, see, look, previous, go to the problem here. Distance given to me is g by 6. We calculated using the kinematic method, right? So here you need to find out what is the distance here, which is g by 6. So therefore, now when you get this distance over here, it started from u equal to 0. It traveled all the way along with this acceleration. So you can find out that this v square should be equal to 0, 0 square plus 2as, 2 into, what is g? What is a? A is nothing but g by 3. G by 3 into g by 6, right? The acceleration which it came down is g by 3. How do I know? See, I substituted here, right? 2m a into g, this one, right? Or maybe if you want, you can go here, right? You can go here. See, I have calculated A equal to G by 3 here. Okay. Now this should now be equal to 2G square divided by 18. This should be equal to G by 9. Right? 2 ones are 2 nines are. Therefore, V should be equal to G by 3 here. Now I'll take this value and substitute over here. So this should now be half into 3m into V square. What is V square? G square by 9. Okay. So now what do we have? 3 ones are 3 threes are, which should now be equal to mg square divided by 6. Now again I will write this as mg square. What is mg square? Mg into g divided by 6. What is mg? From the previous slide we have got, what is mg here? See, mg has substituted as 12, right? So this will be 12g divided by 6, which is equal to 2g. We got the same answer once again. 2g joules here, 2g joules here. Now, which one is easier if you ask? Now, which one is easier? This is easier. This is easier as compared to this. Because you see, the number of steps here are much lesser. But we have taken all the parameters what was determined here. Okay. If you did not know the value of acceleration here, you cannot solve this problem. Why acceleration was required? Because to find out what is the velocity. Okay. So many things are coming in between. So sometimes energy physics is easier. Sometimes energy equations are easier. Sometimes mechanics equations are easier. So it is left to you as which one would you like to take. Fine. Anyway, if you like my video, do share and subscribe to my channel so that it will encourage me to do further videos on all this. Do I have next one? Yeah, I do have it. But now I will be discussing more on friction. Okay. Friction and work energy power. How do you use work energy power to determine the frictional coefficient, or maybe to determine the stopping distance, or to determine the coefficient of friction? It could be anything. Okay. So let us start solving such kinds of problems also shortly in my next video. Thank you, friends, for watching. So key in with me forever. Thank you.